Hey guys, in this video I want to show you how to make a very simple fluid drip simulation in Houdini 21, so let's dive. So if you want, you can get access to the final project file with a link in the descriptions. It includes everything except the fruits because I don't have the right to share it with you, but it includes all the light setup, the render setup, all the materials, and also it includes the tweezers models that I have created directly inside Houdini, and I've used cups to create some textures and some displacement maps. So if you want, you can get access to these project files with the link in the descriptions. So I've created a new blank scene in Houdini, and the first step, like always, is to add a new geometry container. So here we can rename it R&D Fluids. You can dive inside, and the first step is to import your collider geometry. So in my case, I will use a fruit, but you can use any geometry. So here to do that, you can add a file node. You can select the node and you can press P to open the parameter of this node. So here I can click on this little icon on the right to import external 3D geometry in Houdini. And here I can go to the $heap, and under my geo folder I have this little fruits model. And in my case I will use this one, which is the high-res versions. So this is the model I have. At the moment it's quite big. So here you can add a match size node. So in that case it will center the model at the center of the scenes. And here you can press H to just center the view on the fruits. And here you can click on scale to fit. In that case, it will rescale the model on the cube with a size of 1 by 1. If you want, you can change the target size here. But in my case, I will keep at 1. So now you can add a UV quick shade just to get a preview of the texture of your models. So in my case, under the $heap and text folder, I have my texture for the final fruits here. And I will use maybe this one for the preview. And now you can get a nice preview of the final texture of your models. So now let's add a transform node to place it correctly on the scenes. So in my case, for the value of the transform node, I will put the translate on the y-axis to 1.6. I will put the rotate on the x-axis to 80 degrees. I will put the rotate on the y-axis to 42.5 and the rotate on the z-axis to minus 196.25. Of course, you can change the settings of the transform node to place your model correctly on the scenes. And if you want, you can select the transform node and you can select the little gizmo icon here on the left to move your model with the little handle here. So you can move the positions and you can move the rotation with the little handle here. So now you can add a null after the transform node. And here you can rename this null something like out fruits. So here, if you want, you can do your flip simulation with the fruits only, but in my case, I found very nice to add a little tweezers on this object. So here I will copy everything from my original files and I will paste it. So here I can press Ctrl C on my original file and paste it here. So I have modeled everything in Houdini, and if you want, you can get access to the final file to get access to these models. And now you can add a merge node. In that case, you can merge the fruit with the tweezers. So you can select these two nulls and you can plug them inside the merge. And now you have this result. And if you want, you can go to the little edit node, which is red color. And here you can change the value of the rotate to make it at the good position for your own fruits. So if I increase this value to, let's say, 15, you can see I have more space on my tweezers and I can reduce it to 5. And here I have a smaller space. So in my case, I will keep it to the original value, which is close to 10. So here inside the cabinet, I have created some maps for the final texturings. And in the next video, I will show you the look dev part for these scenes. So I have created a mask here just to add different materials on my tweezers. And I will also add a displacement with this one, which is the logo here. I've created a normals with some noise. And here I've created some lines at this specific space of the tweezers to create some extrusions with the displacements. So I'll use that one as a displacement map in Redshift.
Most Houdini tutorials show you tricks. Very few teach you how to build real, production-ready setups from scratch. Artilabs is a premium Houdini training platform for artists who want production-level results, used in motion design, simulations, and high-end product visuals. You get 45+ hours of advanced content, including 2 complete courses where you build high-end animations from start to finish, exactly like in real client work. Every lesson includes full Houdini project files, so you're never guessing. You follow the exact workflow step by step. The library keeps growing every month. And right now, annual access is discounted with an extra 20% off for a limited time. Click the link below. Start building Houdini work that actually attracts professional clients.
So now I have my final collider for the fluid simulations. I have the fruits and I have the tweezers. So here you can add a null to specify this is the collider geometry. So here you can rename this null something like col geo. And now we also need to create a volume for this collider for the flip simulations. So here I found it a bit better to convert it first as a VDB, then convert it back to polygon, and then create a VDB of everything for the final collider volume. So let's do that. So we can add a VDB from polygon. Here for the resolutions, you can go to something like quite high res, so you can decrease the voxel size to something like 0.005. Now you have nice details on the collider geo. You can add a VDB convert, and here you can convert this volume back to polygon. And now you can convert everything back to VDB, so let's add a VDB from polygon. And here you can put the resolution to something like 0.01. And now you can add a null to specify this is the collider volume, so you can rename this null something like col vol. And now we have our collider geometry and we have our collider volume. So we can import these two nulls into the DOP network later for a nice collision between the fluid and the collider object. So now we need to create a geometry to source the fluid simulations. So here you can create any geometry, but in my case, I will use a simple spheres. So we can keep everything simple for these tutorials. So here with the spheres, by default, we have the primitive type on polygon mesh. You can change that to polygon. And here you can increase the frequency to something like 6. And here you can change the uniform scale to something like 0.25. Of course, it depends of the size of your collider geometry. So here, if you want, you can template this collider geo. And now you can move the spheres above this geometry. So let's add a transform node. So in my case, I will change the value on the y-axis for the transform node to something like 3.5. Now I have my spheres above my collider geometry. And now we can convert these spheres to a flip source. So to do that, you can use a node called flip.source. And at the moment, you can keep everything by default. So later we can change some settings. Let's add a null. And here for this null, you can rename it out source. So now we have these three nulls for the DOP network. So you can select everything, you can press C, and you can make them, let's say, green. So in that case, we can import the source, we can import the collider geometry, and we can import the collider volume. So let's create the DOP network for the fluid simulations. And here for the DOP network, you can rename it something like flipsim, and you can dive inside. So at the moment, we don't have anything on the DOP net. So first we need to add a flip solver. You can plug that to the output. You can add a flip object, and you can add a volume source, and you can plug that to the last input of the flip solver. So now we need to add a gravity force, and you can plug that here between the flip solver and the output. So here you can see we have a little box at the center. So to remove that, you can select the flip object, and here you can remove the default subpath. So you can select everything and you can remove that. So first we need to link the resolutions of the flip simulation with the settings of the flip source on the SOP. So to do that, you can select your flip object. You can right click on the particle separations, and you can go to the copy parameter value. So now you can go back to the SOP by clicking on this, and you can go to the flip source. So here you can link the value on the voxel size and also on the particle separations. So for the voxel size, you can right click and paste relative reference, and you can multiply that by 2, which is the grid scale value. And now you can also paste the value here on the particle separations. So right click and paste relative reference. Also, you can change the value of the jitter seed at every frame to avoid getting some stepping issue at the final result. So here you can type the variable $ff. In that case, the value will change at every frame. And now you can go back to the DOP net. So now we need to import the source to this DOP net. So you can select the volume source. And here under the subpath, you can select the source that we have created in SOPs with the spheres. So you can click on these little icons and you can select the source, which is here, out source. You can click on accept, and here under initialize, you can initialize the source flip. So now you can see we have the source on the DOP net. So you can select your flip object, and here you can go to guides and you can go to particles. And here you can change the viz from sprites to particles. And you can increase the particle separation. So at the moment it's very low. So let's put the value at 0.02, and later we can increase this value. So now we need to import the collider geometry inside the DOP net. So to do that, we need to add a merge. You can plug the merge here below the gravity. And now you can add a static object, and you can plug that to the merge. But we need to have the static object on the left. So to do that, you can select the merge node and you can press Shift and R. So here on the static object, we need to import the geometry here under the subpath. So you can click on this little icon and you can select your col geo. Click on accept. And now you can go to the collision tab, and you can put the collision detection to volume collisions, and you can put the mode to volume sample. And here under the proxy volume, you have to import your col vol. So here you can click on that and import the call vol nulls that we have created before. So click on accept. And now you have everything set up for the static object. So now you can go to the flip solver. And here under the substep, you can increase the minimum substep to something like 6 and the maximum to 8. And you can decrease the time scale to something like 0.25. So now you can go to the particle motions. You can add an ID attribute. You can go to the receding tab and you can disable the receding particles. Now you can go to the volume motions and you can change it to swirly. And now you can see that we have a large container in purple with a default size at 50, which is very high. So in our case, we can change the size of this container to something like 4, 8, and 4. And now you can move it up on the y-axis just slightly, so you can put the center here at 1. So now we have this result, and you can hide this container from the scene, so you can disable this little visualize limit. So now you can go to the viscosity tab and you can enable viscosity. So if you want, you can control the viscosity attribute. So if you want to do that, you have to enable these options. But in our case, we will define a value for the viscosity in the flip object. So now we can go to the surface tensions and you can enable that. So we can put the value quite low, maybe at 5 is good. And you can enable the surface tension blur. So you can put the value at something like 0.05. So now let's define some settings for the source. So you can select the flip object. And here you can go to the physical tab and here you can define a density and viscosity value. So in my case, I will put the viscosity at 300 and the density to 5000. So I think it's pretty much it. If you want, you can add a little pop drag on the force. So you can plug that to the particle's velocity. And here you can decrease the air resistance to something like 0.2. And now we have the final result. So you can click on File, Save, and you can run the simulations. Also, if you want, you can go to the SOP and you can increase the little memories here for the cache. So you can go to the cache folder and you can just increase the cache memories. So now you can click on play. So this is the result I have for 240 frame. If you want, you can simulate a bit more frame. So it's a bit slow at the moment because we have set the flip solver with a timescale at 0.25. So if you want, you can increase the speed later in post. But in my case, I will simulate, I think, 300 frames. So you can increase the value here. Instead of 240, you can put the value at 300. So now you can define the final resolutions for your flip simulations. So this depends on your computer speed. In my case, I will put the value at something like 0.005. But if it's a bit too slow on your machine, you can increase the value to something like 0.01. So of course, it's up to you. You can change the value if you want. So now you can go back to the SOP level and you can add a DOP import field. So you can drag and drop your DOP.NET into the DOP network field. And here for the DOP node, we have to select the flip object. So you can go to these icons and you can go under the flip sim, which is a DOP.NET, and we have to select the flip object one. So here on the DOP import field, you can select the flip fluid preset. So it will import the flip fluid simulations on the SOPs. And now you can put that in cache. So let's add a fluid compress. So here on the particle separations, I will put the value the same as I've set on the DOP.NET. So in my case is 0.005. And here I will disable the cull bandwidth. So now I can add a file cache node and I can rename it something like flip sim. And now you can put the file path to explicit and you can put that under the cache folder and under the $OS folder, which is the name of the node. And here you can put that in cache for 300 frames. So this is the result I have for the cache. So now we need to unpack the points. So let's add the unpack points. So at the moment we have some particles and we need to convert that to VDB to create a geometry based on that. So let's add a VDB from particles. And here for the voxel size, I will put the value to 0.005 and I will decrease the minimum radius in voxels to 0.1. So now let's add a VDB reshape SDF and let's keep the operation to delete and the offset at 1. And now let's add a VDB smooth SDF. And here for the VDB smooth SDF, you can change the operation to Gaussians. And here you can add a new one. So now let's add a VDB reshape SDF. And this time we can change the operation from delete to erode. And now you can convert that back to polygon with the convert VDB node. And here you can change from volume to polygon. So now you can add the normals to this geometry. And here for the normals, you can set them on the points and you can put the weighting method to face area. So now let's add a smooth node. And here for the smooth, you can increase the value just a bit. So let's put the value at 15. And now you can add a smooth, but this time for the normals. So you can remove the position attribute and you can replace them with the normal attribute, which is n in uppercase. And here you can increase the strength to something like 30. And now you can add a nulls to specify this is the output for the fluid. And you can rename it out. And now if you want, you can select the fluid, you can select the fruits, and you can select the tweezers, and you can select everything and plug them into a merge just to have a little preview of everything. So this is the result I have at the frame around 240. Of course, it's up to you. You can change some settings if you want, and you can also animate the source if you want to add some extra motions for the flip source. So that's it for this tutorial, guys. I hope you enjoyed it. You can get access to this final project file with a link in the descriptions, and in the next video I will show you the process to do the lightning on the rendering of a similar scene. So I'll see you in the next one. Bye bye. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxa.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.